the box that you are going to use it for the whole semester. So before that, we guys go for the few theories that you need to know. So go back to the theory over there. So in the box you are given PIC 16F887A, and by physically you can look at the package is 40 pins. Okay. Just make sure that you can get PIC 16F, not 18F. 18F is the brothers of the family. Alright? So this is a microcontroller, 40 pins, 40 legs. Anyway, so physically will be like this, and the block diagram consists of all the modules and the CPUs inside here. Right? So if you open up this one, you can see that what is actually inside is like this. It's basically like this in the semiconductor world. Okay? This is how they fabricate in the production, especially about these silicons. This is all very, very if you work in industry, you know that this is very delicate things. Right? The next one. So we go back to the most important part that you need to understand. Again, this has been shown in the first chapter, but this is a recap again, and you need to understand that. Why? So we have three memories inside the memory controller. The controller has got the whole system has got three memories basically. The types of memories are RAM, ROM, and the last one is EEPROM. But eventually the EEPROM is not inside here. EEPROM is on the board. You can see that on the left bottom of the board, you can see that there's instructions for the EEPROM. The EEPROM is the memory for you to save data while executing your program. Whereas your RAM and ROM is two different things. This is the most important part versus microprocessor. ROM is the one that is going to be burned with your program. When I say burn, you are burning the program. Burning means you are putting the program inside the microcontroller. Like you're burning your CD. Whether you have the CD yet, I do not know. Your generation not sure yet. When we have the CD last time, we have to burn most of the data into the CD. We call it a burning process. It's quite hot, basically, when this process is doing. It produces heat. So that's why they call it burning. You burn something. Once you burn, normally it's permanent. That's the reason why they call it burn also, right? When you burn something, it's permanent. Or you flash it. There's another term they call it, they flash it. Okay? So you can burn or you can flash your memory, they call it. That's the term. Flash or burn. So ROM is the one that's very permanent. When you have your hex file is your machine file, also machine code, that one that contains the machine code for your program. When you burn to the microcontroller, it will be permanent on the controller until you erase it back. Erase it back means you have to erase it correctly. If your power is down and your program is there, when you power up the system again, it will work fine. There will be no issues. For example, your vending machine over there, your vending machine is the big machine. There must be a controller inside there. That's why you power on and power off. You can bring out somewhere else, the machine is still working because the memory have its program. Okay, so that is the ROM. ROM is permanently being stored, so also known as program memory, and this is a flash technology by providing signal programming at 13 volts. So if you want to burn it, you have to give 13 volts for this guy, and then you can burn your program. The operation is only 5 volts for it to operate, but to flash it, it requires around 13 volts higher. Okay, to burn it. We are going to do that process later. Next one is the memory for RAM, random access memory. Again, they are playing with registers most of the time. This memory is not permanent. Once you shut down, it's gone. The whole information inside there is gone. So you have to use it later again. Normally this is non-permanent informations that you need to do. Okay, so you are going to go and read later what is the contents of RAM and ROM over there. So the last one is EEPROM. Basically, it should be the same like this, same like ROM. The characteristic is just same like ROM, but the difference is it can be changed upon while executing. That is the biggest term over here. However, EEPROM can be changed during operation, which means that when you run your program, you can use the EEPROM as your storage. Okay, like your handphone again, I tell you so many times, like your handphones, when you take a picture, that one is executing, taking a picture, and it will save it to where? It's in internal or external drive, right? You are going to save it normally at your external drive, which is your SD card. Your SD card is another type of a permanent memory where you plug out and you plug in somewhere else, you can read back the information. Correct? So it means that the only thing that different is the EEPROM is the one that can be changed during execution, whereas your ROM cannot be changed upon while doing your execution because it's holding your memory, it's holding your program. That's the difference, the biggest difference. But the other thing is very permanent. It's permanent memory, it's permanent memory. So you have to understand that. If the question asks the differences, this is the differences about that. When you understand that, you can just write down. Okay? Right. Okay, next one. The rest this is all about the contents of the ROM and RAM. So I just go through one, you can read later. Alright, what is that one? Maybe we have another version over here. So we have the ROM and RAM organization. You cannot memorize all, so you are going to touch few of them. Alright, this is just for a while. Okay, this is the registers. Registers is under RAM. Okay, under RAM, then we have the registers, and the registers are divided into two categories. One is general purpose, and the other one is special function registers. These two categories, So this is under RAM. So the difference is that one. Core CPU for this one, and the peripherals is for this one. Core is for to control, and peripherals is another modules that you are going to use. For example, the A2D module, something like that. You are going to touch it on the RAM. Okay, the next one. This one I'll skip on there, this one later, this one later. This is basically the RAM you are going to touch in the chapter. I don't want to touch it now. Okay. Just a quick one. If you want to understand how it works, it's quite simple. You have a car. So how to make the car move? So you have to have few components to make it move. Same like the controller, this one. If you want to use it, there must be the basic things that you need to have that it can work. So you have to understand these four first. Right. Okay, example first. Let's see the car. Car is very simple. You are using car most of the time. So the thing is very simple. You must have a driver, you must have the gas, or you must have the steering to control it, and of course you must have a tire itself so it can work. Same goes to microcontroller. So what is the basic requirement? Basic requirement on the controller. If you look at the controller board over there, so there must be this component, basics component. The first one is the power supply. If there is no power, there will be no functionality on the microcontroller. So look at the board on the top left. The top left is the source for the supply. So you are using converter, right? Your power supply is AC supply, and you should have the power converter. Man, converter mana? Power converter. Converter tu burner. Converter. Power converter. Okay, you can take the power converter the other side. There's one, each of the table take one converter. So that converter is not used for charger. That's why we don't call it charger. Charger also have the same concept. Your phone charger is also converting the AC current to direct current. Because your handphones is electronic stuff, so it requires direct voltage. So the function of that one is converter. So you look at that power supply on the top left, so you have to plug in. I recommend you, if you have your team later, you can bring your own multimeter. It's much better to understand. Alright, so if you plug in, that is the source for your 5-volt line. The converter starting from 12 volt, if I'm not mistaken. Let's look at the setting of your converter. Is it 12 volt? Normally your converter will give higher levels of voltage. Then it will go through the board by this 5 volt circuit. It will cut your voltage from either 12 or 24 volts to only 5 volts. So the output here, from here, V in is around 12 to 24 volt, and after this IC, and the output will be only 5 volts, ground and power. That's why if you have a multimeter, you can play around. You understand the concept. This one, you learn it in first year lab, if you can remember. For those who are direct entry, I'm not really sure, but maybe you learn it from your poly or other IPT. For UTEM, I know that this is in the lab for year 1. If you can remember that, that is the functions of the converter. Right? That is the first one. Okay, so you can see that on the top left, there are 2 ICs which have 3 legs. On the top left, you can see that there are 2 ICs with 3 legs. That is one of them. 78 something something. You can read the body of the IC. Is it 7805? You can find out? Okay, that is the IC. So this IC is receiving around 12 to 24 volt. You will cut down to only 5 volt only, and then will supply to this one or supply the board. Okay, 7805. Okay, alright, remember that. So the first one is the power supply. The next one you need to understand, it must have this one first. They call it crystal clock. You can find it near to the green connector. Green connector which holds the PIC. They call it crystal clock or oscillator. And it's labeled as Y1 on the board. If you can find out Y1, that is the crystal clock. And that 2 pins must connected to the PIC at pin OSC1 and OSC2. That's why you can see that the crystal clock is located near to the 2 pins. The green connector, you can see the labeling, OSC1 and OSC2. That is oscillator. The clock will give you the pulse. That is called the megahertz over there. That's why every PC got the controller CPU must have clock also. Because clock is a compulsory. Without clock, it does not know when to function or execute. So you must have power. You must have the oscillator. Right? And this is another thing which is very important, which is related to the master clear pin. This is important because I told you last time, if your system got browned out or got problem, you can reset. Same like your PC or your phone. Every time hang, you are going to reset it, right? Remember that? To put it back to the original condition. So in PIC, pin number 1, on the green connector, pin number 1, they call it M clear, master clear. So I'm not so sure where's the right reset button on the board. You can find out later. I don't know where. There must be a reset button to reset the whole thing. Alright, this is why this is the circuit and its position, its current first position. This is a 5 volt direct. Means that it must be connected to 5 volt directly to the pull down switch, which means that your master clear is only active when you give 0 volt. When you press your button, when you press this button, this one will be connected, correct? Huh? So it means that that particular pin number 1 will only receive 0 volt to reset. By condition, it must have 5 volt to make it pull up lah. If you do not put 5 volt, it's hanging, it can be reset anytime. It can go up and down. So that's why you need to pull up. Pull up to 5 volt, then you put switch. That switch to make it reset. These 3 components, remember that. This is basic component. Without this one of them, don't use it. You cannot use it. Next one. Again, on this one, PIC basic circuit. So the basic circuit is like this again. The first one is the ground and power just now. The second one is the oscillator. So this is the oscillator. The symbol for crystal clock is like that. There's a box with 2 lines. This is oscillator. And the last one is the master clear circuit. So this one is the power supply circuit. Just now we look at it just now. So you have to remember all this one. The basic parameters. Okay. You don't use this one. This is very old one, like 2012. You are using the red color box. Okay. Now let's understand what you need to know. Turn on your PC first. Turn on your PC. While waiting is to boot. Today you need to know 3 things for you to use before you can use your board. Okay, the first one is the program to write the program. They call it one is the program is micro C. The red icon. Look at the computer. Okay, we are doing it one by one. This is to write your program and compile it. Write and compile. Okay, the second one. The second one is Proteus. What's the function for Proteus? Proteus is to simulate your hex file, simulate your program. If your program is working there, then you can burn on the system. And the third one They call it the PIC Kit 2. The function for this software is to burn or flash the program to controller. Alright, open up these three software first. Let's try Micro C first. In Micro C, we are using it yesterday. Let's try the Micro C, this one first. There are two Micro C over there. Look for this icon, Micro C, the one with the more white color over here. Turn on that Micro C software. Version 8.2. Okay, they give you an example over there. Okay, that example, or you want to see this one as a black color or white color? You can see. Everybody got the same page with me? Alright, got the same page with me, yeah? Okay. Let's try to write a new program by using this program. Okay. Control A all, copy first, go to your text. Notepad. Just paste over there first. And then you can close this one. Now the homework is very simple. Copy and paste. Put here and there, put here and there. Right, now we are going to start a new project. Ready? You must be at the same page with me, eh? Micro C. So how was the problem? Huh? Sorry, cannot hear you. No, I just copied to the notepad just now. Take the whole program, copy the notepad first. We haven't started yet. Okay, now, when you do programming, try to behave yourself. Put it somewhere that you can find it. That's the properly done. Okay, right. Now, go to File, or you can see anything. Go to Project. Go to Project, New Project. Okay, to make my life easier, I put somewhere else. I put my project path to the desktop. Just to make myself very simple. Okay, make the folder test 1. Open up this one and then OK. Put somewhere that you want to see. So if you look at the desktop right now, test 1 folder, there's nothing over there. Clear? If you want to go to desktop, you just hit Window D. Window button and D, you will go to your desktop. Okay, look at the test folder, there's nothing yet over there. So it's okay. I want to put down here. Okay, now you are using what device? Is PIC 16F8778. PIC. Okay? Same page with me, eh? Later after you don't ask me. Okay. And your clock, you set it to 20 megahertz. Okay, this one I just want to compute something just to throw out. Compute something. Take this one, LDP underscore off. LDP underscore off, take this one, take this one. Okay, just okay, everything? That's okay. Now go back to your notepad. Copy everything. Paste it back. Okay? Now, you can save your project now. Look at the test one now. I have two files created over there. Okay, now, when you save it, .c.ppc. You make sure that you have these two files first when you save it. Look at your folder. Then, still with me, right? Now you can compile this project, make sure the device is correct, PIC 16F8778, or English is PIC 16F877A, and your crystal clock is around 20 MHz. You compile it using this icon, or you can just use run, or what is it? Not run, tools, project, or view, project, here. Build or this one, same thing. You build this one, look at the result down here. If there is an error, it will tell you error. Let's say I put an error over here. Let's try to see the error. Let's build up this one again. You can see that there's an error over here. So, make sure there's no error. Build this one and go back to your file folder, test just now. Look the result on your files. Now from two files, after you build, there are so many files. And make sure your timestamp is correct. Timestamp is very important for you to debug. I don't want people to upload the old program every time. Every time you build the software or your program, it will create a new timestamp, especially on the hex file. You must make sure that the hex file is the latest one when you compile. Now my time is 9:29. My hex file now is 9:28. Let's compile it again. Look at the data again. Now it's 9:28. Timestamp is very important because when you mix up, there's a potentiality of old hex file is loaded. So have you got this one? Right. Okay, now you have the hex file over here. Now you have to go to your Proteus design. I try to go to Proteus. Proteus is where? Proteus Professional 8.